Hey, what's up, man? All right, so two very easy questions, and then see if you guys can get them, you know?
Oh, thank you.
They have to do with water, both of them. Very easy, you know? So, how's it going?
How's it going, man?
Hey, so you want to give this a shot?
Yeah, I want to.
Yeah. All right, two very easy questions. And let's see if we can get them. Should have had this ready, but they both have to do with water. Very easy. Water, yeah. So, hey, how's it going? All right, so two very easy questions, and let's see if you guys can get them. You know, you guys should be able to get them.
Is the camera on right now?
Yeah, camera's on. Yeah. So again, they both have to do with water, by the way. Very easy. So in this first one, I have 3 water bottles, and I filled them halfway with water, and I painted the water blue with food coloring just to make it easier to see. And I also put a ping pong ball in there just for fun. So another thing to note is that all these 3 water bottles are at rest. So how I'm showing you these 3 water bottles, what's the difference between them, all 3 of them?
Is it just their orientation?
Okay, yeah, you got it. Yeah, you got it. Can you put them in the orientation they should be, I guess?
You said the blue is water,
Yeah,
right?
yes.
Because the ball is floating on the
Yeah,
surface.
exactly. You guys got it.
Yeah.
So if I was to ask you guys, how did you guys know?
Because we know that water
It's like water that goes
the
down.
air always pushes water out of the way, so air is on top.
Yes. You guys got it? Perfect. Yeah, pretty easy,
we
yeah.
passed it.
This first one here, I have 3 water bottles, and I have them halfway filled with water, and I painted the water blue with food coloring just to make it easier to see. And I also added a red ping pong ball in there for fun. So another thing is that all of these water bottles are at rest. But how I'm showing them to you, what's the difference between them?
I guess the angle at which you're holding
The bottle?
yes, the bottom.
Yeah, you got it. Can you put them in the angle they should be, I guess? Yeah. You got it. That's pretty good. So how did you know that? Let me ask.
The water's at the bottom.
Yes.
It's gravity.
Exactly, yeah. The water's always should be in the bottom.
Yes.
Exactly. You got it, yeah. So, this first one, I have 3 water bottles, and I filled them halfway with water, and I painted the water blue with food coloring just to make it easier to see. I also threw in a ping pong ball in there, just for fun.
Yeah.
But another thing to note about these water bottles is that they're all at rest, right? So you know what that means, right?
Yeah.
They're all still. So how I'm showing you these water bottles, let's put another 1, 2, 3. How I'm showing them to you, what's the difference between them? All 3 water bottles.
Difference? One's upside down.
Yeah.
One is the water's sideways.
Okay.
And then the one is just regular.
Okay. Can you flip them?
Can I flip them?
Yeah, flip them how they should be then. You say one is upside down.
Yeah.
Okay. Okay. You got it. Okay. You got it.
I'm assuming that's
No,
what it should be,
you
but-
got it. You got it. Yeah, that was pretty good. What showed you, or how did you know that that's the correct position?
By the water and then the ball just
Yeah,
floating out.
yeah, because obviously when you have air and water in a bottle, the water can never be on top.
Yeah.
Yeah, exactly. It's always in the bottom, and the air is always on top.
Yeah.
Yeah, pretty easy. You got it. Pretty good. Some people don't get it, believe it or not.
Oh.
Yeah, that's pretty good. So this next one again. Here we go. So in this one, I have 3 box trucks, and again, they're halfway filled with water. The only thing is in this one of the trucks is at rest, one of them is accelerating forward, and one of them is accelerating in reverse. So which one of these 3 is at rest?
At rest?
At rest. B. And what would you say B is at rest?
Because it's not moving, so it's just going to just flat.
Still, right? Yeah, perfect. Yeah. So which one is accelerating forward?
This.
Why do you say that one's accelerating forward?
Because when it goes forward, all the stuff goes in the back.
You got it. Yeah, pretty easy, right? Because of inertia, water wants to remain in its position. So when you accelerate, the water pushes back. Yeah. So this one is the second one. So I have a box truck with water as well. The only thing in this one, only one of the trucks is at rest. One of them is accelerating forward, and one of them is accelerating in reverse. So out of the 3, which one is at rest?
B.
B. Okay. Why would you guys say B?
There's no motion.
No motion. Exactly. So which one's accelerating forward?
A.
A. You guys got it. Yeah. Again, why is it A?
Because pushing backwards air.
Because it'll
Yeah.
when you move forward, the air will push the water
Because an
back.
object at rest stays
It's
at
actually
rest
the
until
opposite. I don't know if you knew that. The water pushes the air forward. Yeah, because the water's more dense. So the water is able to carry the water. The air.
The way I know it was A because my dad works for a beer delivering company.
Okay.
And he always tells us how whenever he moves, all of the cases go all the way to the back.
Yeah, because they're at rest, and so once you move, it takes a second for them to go.
Not only that, but all matter has inertia. So it wants to remain in its position. So when you accelerate the container, again, that wants to remain in its position so that, it pushes back. So in this one, I have 3 box trucks, again, halfway filled with water, except in one of these is at rest, one is accelerating forward, and one is accelerating in reverse. Which one's at rest?
Accelerating forward, rest.
Reverse. Okay, perfect. How did you know that?
Because, you know, as you accelerate,
The water would push back.
pushes.
Yes.
this way.
Yeah, 100% of the time, water will always push back in the opposite direction. Even when I accelerate down, the water pushes up, you know? So if I was to release this into free fall, do you guys believe gravity accelerates this down to the earth?
Oh, you're saying like
In
to
free
the
fall.
ground?
Yeah, so if I release this into free fall, you believe
Yeah.
gravity accelerates it down to the ground, right?
Yes.
So if we go into actual physics, you know, and measure, you know, and I actually accelerate the bottle down, we can actually detect that there is a force present by the fact that the water is displacing. Again, the water wants to move up in the opposite direction of acceleration.
Right. It's just faster than gravity, right?
Okay, but here's the thing though, gravity, this kind of acceleration without any effects of acceleration or cause basically shows that there is no acceleration in free fall.
Well, the difference is one of them. Well, there's acceleration in both of them, but you're adding acceleration in the second one.
Okay, so you're saying that acceleration without displacement can exist? So you're claiming that B can be accelerating?
It can be accelerating if it's in free fall without added acceleration going downwards.
I would say that that's special pleading because you would need another demonstration to show this kind of acceleration.
Yeah.
Even when I accelerate down, the water wants to push up.
Yeah.
You know, that's obvious, right? So let me ask you this. When I release like this water bottle into free fall, for example, when it's in free fall, do you believe it accelerates down to the ground or it moves down to the ground?
With
By
the water
gravity?
bottle or the water?
Just the whole bottle in
whole
general.
bottle?
That when I release this, do you believe gravity pulls it to the earth, like
Yeah.
down to the earth?
Yeah.
Right. So when we actually accelerate versus free fall, again, let me get this up right here. When we actually accelerate versus free fall, again, when I accelerate here, we can see that displacement, water wanting to push up.
Yeah.
In free fall, we get no reaction of the water. So basically, free fall shows us that there's no actual acceleration of objects down.
Yeah.
So this whole idea of gravity being a pulling force is actually not real. So I don't know if you heard gravity being a theory, right? Yeah, gravity is just a theory. So they haven't measured this force that's actually accelerating objects down. And the reason why is because there is no force accelerating objects down. And there is also no effects of a force, which will be the displacement, water pushing back in the opposite direction you accelerate the bottle. So again, gravity is just a theory to make people believe that the Earth is a globe. Now let me ask you, do you believe the Earth is a globe?
Yeah.
Right, so the reality is, when I release this object, it's not the object that moves through the ground, it's the ground that moves up to the object. You know, in the opposite. Again, even when I accelerate this bottle down, the water moves up. Again, in the opposite direction you accelerate. Again, exactly, it tries to stay. Any direction, right? So when I actually accelerate down, let me show you guys this real quick. Versus, and so let me ask you guys this before I get to the next one. When I release this object into free fall, do you guys believe gravity moved this towards the ground or accelerated this towards the ground?
It's a force, so it's an
So,
attraction.
yeah, right? So again, if we understand inertia and acceleration of a container with water, when I actually accelerate a container versus free fall, which one would you say I actually accelerated?
Accelerated.
Left or right?
I think it would be like
The right one,
Yeah,
exactly, because that one shows the displacement. The water wants to push up.
Yeah.
The one on the left is free fall, which doesn't show any effects of acceleration. So I don't know if you guys knew, gravity is just a theory. And the reason why is because a measurable force in free fall has never been measured. Not only that, the effects of a force, which is displacement, water pushing back and the air moving forward, doesn't exist in free fall as well. Again, the water's in the opposite direction it should be in free fall. And the fact is because objects don't accelerate down in free fall. The fact is when you release an object, the earth moves up to meet it. So it's not the object that moves down to the earth, it's the earth that's literally moving up. So again, if we can prove that it's the earth moving up and it's not the object being pulled down towards the earth, and up is relative on a ball, you guys believe the earth is a ball, by the way, right? Yeah. And up is relative on a ball, how can the earth move up on a ball? How can the earth be moving up on a ball?
because it's moving through space already.
But it can only move through space in one direction, either this way or this way. And up is relative, right? It's in every direction opposite from the center. So the fact is that it wouldn't work from a globe. That would mean the globe will have to be expanded. You know, if we could prove that it's the earth pushing up against you and it's not pulling you down.
Visibly stretch.
Exactly,
I
it
mean,
would explode.
The Earth is more of an egg, not a sphere, so that's.
But even then, up is still in every direction opposite from the center.
Yeah.
It's-
Physically contort.
physically-
Exactly, which would so
Well, I mean, well,
Can
okay,
you-
wait. To you, what is acceleration? Like,
Acceleration is increasing velocity per second. So the distance
Right.
traveled per second is
So,
it's greater.
so if you drop your water bottle, right, and
Yeah.
you don't add additional force like in the second video, would you say that the velocity is increasing downwards?
I would say it's a visual interpretation that there is an acceleration of a free-falling object, but the
Right.
change in velocity that we witness is a deceleration. So what's happening is when you release an object into free fall, it's not the object being pulled by the Earth's gravity. It's actually the Earth pushing up. So when you release this, it's the Earth that comes up to meet it. So
Well,
this never
I get-
moved down.
I guess. Well, would you agree that like, I guess the general theories of gravity that like objects are it's like it's not one is attracted to the other; they're both attracted to each other. Right?
Well, 9.8 meters per second, right? It's the alleged acceleration in free fall.
Right.
You know how fast that is?
and like visually.
In miles per hour. So
No,
in the
I
first
probably
second, it's 22 miles an hour. In the second second, it's 87 miles an hour. So that's the kind of acceleration they're claiming in free fall by this 9.8 meters per second squared. If we were to accelerate half that distance vertically, I mean horizontally, we get the displacement. Again, this is only 4 feet. If I accelerate 4 feet, not even 4 feet, 2 feet, in 1 second, we get that displacement. So how
Right.
is it that we're supposed to believe that this can accelerate down, at 78 miles an hour in 2 seconds without that displacement?
Well, I feel like it's hard to
mean-
visualize here because when you drop it from down here, right, that's not even a second.
Well, even if you dropped it from the top of that building, that water's never going to displace. The water will never move up, even though they're claiming.
Yeah, well, because the bottle and the water are displacing at the same rate.
Yeah. So right now, everything's in motion right now. So you have you feel the pressure under your feet right now, right?
Yeah.
But we're being told that it's gravity pulling us down to the earth. But the fact is, it's the earth pushing up against you. And because your body has inertia, it wants to remain motionless. It resists that motion. So that's why you have weight right now.
Oh,
So again, if we could prove that it's the earth pushing up, and obviously gravity is just a theory that has never been proven, and up is relative on a ball, how can the earth be moving up on a ball?
you can't.
It can't. It will explode
Yeah.
because up is in every direction from the center. So that's why this whole idea of gravity has to be pushed before they even push a globe Earth. So I don't know if you've heard of flat Earth.
Yeah, I've heard that. Yeah.
So flat Earth is a psyop because over 95% of flat earthers and content creators claim the Earth is motionless. So they don't have an explanation or a force to why objects fall to the ground. So they're on the same boat with gravity. They claim that objects get pulled down by a magical force that doesn't cause displacement. So again, the flat Earth and the globe Earth are both the same.
Yeah.
They're both psyops. The fact is the Earth is level, meaning horizontal, and is pushing up against you. It's literally moving up. So that wouldn't work from a globe. The biggest lie on Earth is not really the globe Earth, it's the fact that people claim that objects accelerate in free fall. So that globe Earth requires that belief that when you release an object, it's the object that moves down to the Earth and not the Earth moving up to the object. Why? Because again, the globe Earth wouldn't work. Now, I know if you guys heard of flat Earth, right, before? So this is where the flat Earth is a psyop as well. Over 95% of flat earthers claim the Earth is motionless, which means they also claim objects accelerate down in free fall. So these flat earthers are keeping the whole gravity idea alive, which is keeping the whole globe Earth idea alive. So most of flat earthers online, over 95% of them are gatekeepers. Have you guys heard of that term? So they're all bullshitters as well. They're all liars. The fact is the Earth is not flat. The Earth is level. Why? Because level is an orientation, and orientation requires motion. So the Earth is level, perpendicular to the vertical, which is the Earth's motion. Yeah. So you're claiming that this force can accelerate everything in the container, like it's
Yeah, like
glued,
the whole
like
thing
it's
is
glued.
accelerating the same rate down.
So you're claiming that this force can glue all the molecules together and accelerate them without displacement. So it's like it's frozen.
It doesn't have to glue, like when you're dropping it here, right? Obviously, there is still some like minor movement in the water.
Well, that's
right?
because the water's always moving. It has to be.
Well, like if you're sitting it straight without any movement.
Like right now, look, you can see that it's moving. It takes a while to be completely at rest. And even when it's at
Right.
rest, there's still motion within the water. So I get what you're saying, but what I'm talking about is the displacement, the reorientation of matter within the container. That's what happens when we accelerate. Matter reorientates relative to the direction of the force. In free fall, we don't have that reorientation because there is no acceleration. I don't know if you knew gravity is just a theory. And a theory means it hasn't been proven, it's just an idea. So
yeah,
this,
but
so
I still think it can be useful. Like there's certain things that you obviously can just never prove, but it
Well-
simplifies and explains a lot of things.
well, what if we can't prove that it's actually the Earth moving up and it's not objects moving down?
I mean, I would probably, obviously I probably haven't heard your argument as to why, but
I can explain it very easy.
yeah, sure, but just
Yeah.
the reason I guess I would say is that the proofs for gravity, as we know it right now, like technically it's not even that, like I would say the reason we call it a theory is not because we don't have a lot of evidence and scrutiny to say that, hey, this is something that's consistently true.
Sure.
It's more so that we have a very, very high barrier for what we don't consider a theory and like reality, right?
Sure.
So I would say that probably whatever proof you can give that gravity is a different way, like pushing upwards, is probably definitely also not sufficient to just be beyond a theory and just be reality.
Right. So here's real quick. I know you're saying, well, how can you prove that it's Earth's motion? Easily. So when you release a helium balloon, right, it has a buoyant effect, right? And what direction does a helium balloon go?
Relative to us, upwards.
Up, right? So I recreated buoyancy in a contained system right here in a van, to be exact. So again, when I have a helium balloon and an apple hanging from a string, right? So when I accelerate the van is also moving the air in that same direction, and anything that's less dense in the air will also get pushed in that same direction I accelerate. So what direction would you say I accelerated here?
Forward, like this way.
Yeah, to the right, exactly, because the helium balloon is being pushed in that same direction, because the air is also being pushed in that same direction. The apple only appears to go in the opposite direction of the force because the apple wants to remain at rest. Because the air's not dense enough to push the apple like it did the helium. So the apple only appears to move back towards the back of the container or the wall or the van. So it's the same principles here on Earth. When I release a helium balloon and an apple, the helium balloon is being pushed up by the air, which is being pushed up by the Earth. The apple is more dense than the air, so the air's not able to keep pushing it up, so it starts to decelerate.
So you think it's about like density is why we're
the density, it just things that are more dense than the medium that surrounds it only appear to fall down because of inertia, because they want to remain motionless. So, I mean, do you have any questions for me? I know.
No. Are you a teacher? Or?
No, I'm not a teacher. I just come here to challenge the students.
Oh.
So I came across this in 2016, so 8 years ago. And believe it or not, it's the most heavily censored topic online right now, by far, any other topic. So that's why I'm out here speaking to people, because nobody's talking about this. Nobody. Everybody. Again, even flat earthers are talking about magical forces in free fall. Again, because the globe Earth requires that.
Yeah.
I would say all these flat earthers are all gatekeepers. Have you heard of that term?
Yeah, gatekeepers.
Yeah, they're all gatekeepers. Most of them. Over 98% of flat earthers on YouTube, especially content creators, are all gatekeepers. That's how controlled this is. So again, they're trying to keep this idea of gravity alive, because without it, if the Earth is pushing up, how does that work? It wouldn't. So again, this is the biggest lie on Earth, that objects accelerate in free fall. They don't. It's the Earth pushing up. So again, you guys know, heard of buoyancy, right? Like when an air bubble is rising or a helium balloon rises. So buoyancy is actually an effect of a container that's moving. So again, can I show you guys real quick before you guys go? So in this example here, I have a helium balloon in a cargo van and an apple. Can you tell what direction I accelerated the van? Left or right?
I think it would be right.
Exactly.
Yeah.
So what happens when I accelerate to the right, the air inside the van also gets pushed in that same direction, and because air is more dense than helium, it's also able to push it in that same direction. The air is not more dense than the apple, so the apple wants to remain in its position in space because of inertia. So again, just like the water pushing back in the opposite direction, the apple is also trying to push back because the air is not dense enough to keep pushing it like the helium balloon. What the hell is that? And again, the
I mean,
medium's not-
obviously, like a lot of the general principles of of gravity are more like planetary, right? It's like if we're just observing on just Earth, right? We would never be able to. I guess a lot of the proofs that we have for gravity, especially in like observing, other planets, right, and other stars that we see in the universe, that wouldn't really be explained for. I feel like a lot of that comes from observation of a much greater scale than we can observe from sitting here on the Earth.
Can we physically prove something just by observing it?
I don't know. I would say maybe.
I would say using vision alone, none of your other senses, just vision alone, you can easily be fooled. Because you could be looking.
I would agree with that, but I would also agree you could probably set it up to a point where it's beyond scrutiny, where the potential to be fooled is reduced to insignificance, right?
Right. Yeah. So what I've done a lot of tests that show that there is no force in free fall, and that force is actually the Earth's motion. So I would say that these are undeniable facts of reality that contradict what we're being told about the Earth. Now, am I going to go with what reality shows me and what can be recreated here on Earth to create the effects that we experience, or am I just going to go with man's interpretation of a theory that he can't prove or demonstrate in any other vector?
Well, I feel like most of the experiments that you can do, right? Like obviously whatever experiment that you're going to do, assuming gravity, you know, in its theory is completely true,
Yeah.
right? It's going to be explainable, right?
Yeah, sure.
So I would probably say that, okay, just to explain, I'm not like a physics major or anything.
Yeah.
Like I have no I have no extra knowledge of physics except for like what I took in high school.
Sure.
But I would probably assert that pretty confidently that the
Bless you, by the way.
experiments that you do could probably be explained by like principles of gravity. Just maybe there's some sort of like either a misinterpretation or, you know, some sort of flaw in the design of the experiment.
Right.
Again, like I'm not a physics major, but I would probably say that if you were to approach, let's say, like a physics professor, right? I'm very confident that they would be able to explain whatever experiment,
Yeah.
you know, the outputs of whatever
Yeah.
experiment.
Yeah, I've never really thought about it like that.
No,
about
yeah.
the globe like pushing up, because even can I see it, bro?
Yeah, definitely.
Even if it were like to go up, then like if you're on the side.
Yeah, exactly. It's not up.
Fly off,
That's
yeah.
going that way. You know. Yeah, exactly. It has to be growing in order to explain that.
Yeah.
So you know of buoyancy, right? When an air bubble is rising,
Yeah.
or when a helium balloon moves up.
Uh-huh.
So the only way to recreate buoyancy is when you have a container, for example, like this. Look, I did a cargo van. I put a helium balloon in there and an apple. The helium balloon moves in the direction of acceleration because the air is also traveling in that direction. Because the air is more dense than the helium, is able to push it forward. The apple is more dense than the air, so it just appears to swing back, but it's being left behind. That's the thing. The apple's being left behind. The
And that's
apple
accelerating?
It's accelerating forward right now. And again, buoyancy shows you the direction I accelerated. So again, the apple only appears to do the same thing as the helium balloon because it's being left behind. It's not actually being pushed back. You know what I'm saying? Because the whole container is moving. So when we release a helium balloon here on Earth and we release something that's more dense, it's the same principle. So the air is pushing up the helium, but the air cannot push itself. The ground's pushing up the air, creating this pressure up. You know, again, and anything that's more dense than air, the air cannot keep it pushing it up, so it just appears to go down because of inertia. Matter wants to remain motionless, and we're all in motion. So free fall means free from any force. So again, exactly. And Einstein's theory of relativity, he claims that gravity is not a force. That's where they come up with their bending and warping of space-time. That's just bullshit to try and explain away that fact from a globe.
Yeah.
So they claim that there is an upwards push, but this downwards flow of the bending and warping cancels it out. So it's like all retarded. You know, the whole Einstein theory of relativity. If anybody actually believes it or takes it serious, just shows that you're not really thinking. You know what I'm saying?
But yet they don't really make a stink. It's just you learn this and there.
Exactly. They don't even. If you start asking like logical questions, you know, you start getting in trouble or stuff like that. You know.
Yeah.
You know. And again, if you don't answer that the correct answer like the way they have it on the test, you're not gonna pass. Exactly.
Yeah.
So that's how they're pushing this on people. You know, by forcing it onto people. And again, they admit it's a theory because it has never been proven, and it never will be. Because the reality is the Earth pushing up. Buoyancy shows us that.
They should have said that at the beginning.
Right? So real quick, so when I release the helium balloon, what do you think is happening? Why does it go up?
Because the air density is like, you know, it wants to reach somewhere that's...
But why does it want to reach somewhere that's dense?
Because helium gets attracted by...
The fact is the same principles. The air is also moving up. Oh my God.
This is a test of the emergency notification system. No action is necessary.
Not even UCR students are getting... Alright, drivers are getting nuked.
Yeah. So again, when something that's less dense like a helium balloon rises, it's the same principles. The air is also pushing up. Exactly. But air cannot push itself. So what's pushing up the air? It's the Earth. Again. So the Earth, again, is pushing up against you. It's not pulling you down. That's the reality. And buoyancy shows us the direction that the force is being applied. Because buoyancy is a force. Density is not. Density is just inertia, an object wanting to remain motionless. So it only appears to move in the opposite direction of force, which is up. You know. So I actually had a conversation, just 40 minutes, with a scientist, you know, a professor, you know, I don't know. And it's on my channel. You can check it out after. But real quick before you go, if we can physically prove, again, because buoyancy is an effect, in my opinion, of a contained system that's in motion, buoyancy showing you the direction of the force. If we can prove that it's the Earth pushing up on you and it's not pulling you down and it's literally moving up, and up is relative on a ball, how can the Earth be moving up if it's a ball?
I mean, I wouldn't say that. I'll probably just disagree with like the fact that you can
You would just disagree that it's not moving up. But let's say hypothetically that I'm not telling you to
Because I
accept,
don't. Like,
it wouldn't
it's,
work,
it's,
right?
It's moving up relative to us, right? But we're also on that like ball.
But
right?
if up is this way and this way and that way and that way, how can it move
Yeah.
up simultaneously in those directions at the same time?
Well, that's like the theory of gravity, right?
Well, gravity is opposite. They're claiming a force flow down towards the center. But if we could prove that that flow
not
doesn't exist,
necessarily. It's gravity is that we're attracted to, like, I'm attracted to the Earth, and the Earth is also attracted to me.
towards
right?
the center, though, you're attracted towards the center of the
Yeah.
Earth, right? My thing is, if we could prove that that flow or that gravitational flow down towards the center doesn't exist and is actually the Earth moving up, the fact is it wouldn't work from a globe. So the globe Earth requires this idea or this theory of gravity being a pulling force.
I feel like there's
It
a kind of
requires it.
disconnect here, because when you say moving up, you in principle are talking about something that I'm in principle probably like not thinking the same thing. Because when you say up, I think like up relative to us on the globe, right? But that's probably a separate thing, and like what you're talking about, like up, I guess, in reality.
Yeah.
So there might be like a difference in, I guess, language there when we're using like.
Well, that's
more
the thing. An
careful-
object can only move in one direction at the same time. This object
Yeah,
cannot
of
move up
course.
and down at the same time, right?
Yeah, yeah.
So the fact is the Earth has an upwards motion, again, only in one direction. And because the Earth is not a ball, it's actually a level plane, everybody's up is the same. It's all the same. So they're trying to tell us that everybody's up is relative.
I just
And that's-
wouldn't agree that like it's upward motion that's
It's causing buoyancy, you know. And in free fall, when you have an air bubble rising, let me show you real quick just before you go, because this is very important, believe it or not. When you have an air bubble rising, that air bubble doesn't rise anymore because it's not being pushed by the Earth. So right here, when I release it into free fall, look at the air bubble right there. It stops being pushed up. It just turns into a sphere. Look, it's being pushed up when I'm holding it. As soon as I release it into free fall, that air bubble no longer moves up or down because it requires the Earth's push. So when something's in free fall, it's not being pushed.
Yeah, it's
you
not
know. So that air bubble can't move through the medium anymore because it requires to be connected to the Earth. Again, buoyancy is an effect of the Earth's motion. You know. So.
It's cool.
No, yeah. Have you ever heard of that before? Probably not, right?
Never really looked into it either.
Yeah, I know. I'm telling you, a lot. Again, all of these flat earthers are a turnoff. All these motionless flat earthers, and that's the whole point. They're supposed to just say a lot of stupid shit. You like the globe earth. Again, no offense, but it's to turn people off to this whole topic.
Yeah.
The fact is, you know, it's the biggest, most important topic, and that's why it's the most sensitive. So, do you have any questions before you go? I know I don't want to keep you too long.
Do you have like an Instagram?
Oh yeah,
account?
my YouTube. Check it out, man. You can take that with you.
Oh, I can take it.
Yeah,
Okay.
the inside of the 6 main proofs that debunk the globe, besides the Earth's motion, which is the number one. But you know, give it a look, and yeah,
man.
yeah. Thanks for the
Nice
chat.
to meet you.
Yeah, nice to meet you too, man. William. All right, man. Thank you. I mean, do you guys have any questions for me before you guys go about this topic?
The emergency alert system.
No, yeah. I'm glad you guys stopped. Let me give you guys my channel. And you guys can check it out. You know, I have debates like this all the time. Well, conversation, because reality is not up for debate. You know, reality is what it is, and it's just up to us to understand what's really going on. You know, so inside of the 6 main proofs that debunk the globe Earth, apart from the number one, which is that objects don't accelerate down in free fall. You know, you guys can give it a read, and yeah, I mean, thanks for stopping. Yeah, appreciate that. All right, you guys have a good one. And that's where this whole topic goes. How
Right.
what would be the mechanism of buoyancy in your mind? Can you recreate buoyancy with your alleged claim? Because I did. I can recreate buoyancy again by accelerating a container with air,
Right.
and something that's less dense than that gets pushed by the air because that's buoyancy.
I mean, I guess my default answer would just be like, well, again, I'm not really like educated in
Sure.
this matter, but like I probably don't even understand most of the concepts that revolve around buoyancy.
Right. Well, like let me just show you this one. It's similar to the band. The ping pong ball is red, and
Yeah.
it's a steel ball. What direction do they accelerate here? Left or right?
Ping pong ball is red. You are accelerating to the left.
You got it, exactly. So a lot of people would interpret that the steel ball moved towards the wall of the container, but the fact is the wall of the container moved towards the steel ball.
Yeah.
And then the ping pong ball did move towards the container. Again, it's the same principles. When you release a steel ball here and a helium balloon,
Yeah.
that steel ball didn't move down towards the earth. It's the earth that moved up. It's the same principle.
I'll definitely check out your
Definitely.
YouTube video with
Yeah.
the professor. Was
Yeah.
that a physics professor? Or?
I'm pretty sure it was. You could check it
Okay.
out.
I
you could
definitely will. I'll take a picture.
Yeah. Sure.
Because obviously, like a lot of the concepts about like buoyancy and
Yes.
even simpler stuff than that, I
Yeah.
probably like have never even studied.
No, yeah, you should look into it. It's
In
very
high
easy.
school.
Yeah, it's very easy to understand, man. Just
Yeah.
check it out. But
right,
thanks for the
well,
conversation.
of course,
Appreciate
it's
it.
nice
Yeah,
meeting you,
yeah, nice to
too.
meet you too.
Yeah.